So we can where the gradient of this function is equal to 0. So you see here the first section where it's equal to 0 is going to be this section here, which is going to be from negative infinity up to negative 2. Now here you got to notice that this part here at negative 2, we just got to check if there is a gradient here. Now the gradient at negative 2, where this joins us, is actually a cosine function. And because we know that the turning point here is at 2, we know that the other turning point is going to be at negative 2. So where these two functions join, the gradient is the same. So it's a smooth change in the gradient. So therefore the gradient exists at this point. So therefore there's going to be a gradient from negative infinity to negative 2. Or we get another turning point here at 0. So we include 0 here, and the gradient is 0 at 2 rather. For the next part, looking where the gradient's negative, we can see clearly it's going to be this section here, and the third section here. So here, where it's negative is going to be negative 2, but we're not going to include that because obviously it's 0 to 0, not included. And then this section here from 2 to 3, and we won't include any of these values. And then what we want to do is do the last part here, which is going from 3, but not including 3, to infinity. Okay. So where the gradient's positive, there's going to be one section where the gradient's positive. That's going to be in this section here. So think about the x values here. So it's going to be from 0 to 2, but not including these values. Looking for where the function is differentiable, where there's going to be a gradient. So we're looking at the function, thinking where it is smooth and continuous. So you see here, as we discussed, this is going to be a smooth change in the gradient. Smooth. So the only place that there's not going to be a gradient is going to be where it's not continuous here, where x equals 3. So it's going to be differentiable, or the gradient function is going to have a domain of all real numbers except for 3 because it's not continuous at that point there. Where it is strictly increasing, we'll see here, this is where it's increasing. So remember, for strictly increasing, we need to make sure that we include the points of 0 gradient as well. So we're going to be going from 0 to 2, but we're going to include these points of 0 gradient. And the last part here, so we've got a vertical translation. We want to find out where there's going to be no solution. So if we move this graph up, no matter how much we move it up, we're always going to have a solution because of this part here. We'll be going down to negative infinity. So the only way that we're going to have no solutions will be to move the function downwards. And we'll have to move it down more than 3 for there to be no solutions. So d will have to be less than negative 3, and then we'll have no solutions in this function.